Welcome to all of you. Today we are going to discuss the topic covalent bond. We know covalent bond it is one type of bond produced between similar or different atoms by the sharing of electrons. That means this type of bond is produced between same type or different type of atoms by sharing of electrons. Usually this type of bond found between nonmetals. Because nonmetals has tendency to accept electrons, that's why no loss of electron takes place from the nonmetals. That's why to satisfy the noble gas configuration, they share their outermost electron to form covalent bonds. What are the examples of covalent compounds? That is covalent molecules, that is hydrogen, oxygen, nitrogen molecule, hydrochloric acid, water, carbon dioxide, ammonia and methane. These are some examples of covalent compounds and all that is covalent molecules. If you see in this case how the covalent bond is produced. Here two dogs, different types of dogs, they are coming with one another with one bone. They have a single bone with them. When they are coming closer, then they are sharing this bone. That means they are fighting for the bones. So both dogs, they are sharing these two bones with each other. So they are coming with single bones, again sharing with two bones. So that means these two bones is shared by the two dogs, we can say. Similarly, here this figure indicates one is hydrogen having a single electrons, another is fluorine having one shortage electron in its outermost shell. As it has both, hydrogen has one electron shortage and fluorine has also one electron shortage, because fluorine has 7 electron outermost shell, so 1 electron is shortage. So both dogs, you can say like this, both when they are coming with bones, with one single bones, then these two dogs share these bones with each other. So this is the example of one sharing of bones between the dogs. Here you see this is the chlorine molecules produced by the combination of two chlorine atoms. Here what happens, if you see, chlorine has 7 electron in outermost shell. Chlorine has 7 electron in outermost shell, another chlorine also 7 electron outermost cells. So they have a single electron less, a shortage of 1 electron in between them. So when they come closer, then they contribute 1 electron each. Both chlorine atoms contributing single electrons, then these 2 electrons remain in between two atoms and these two atoms share these electrons. So we can say this is a sharing of electrons between two chlorine atoms. During the sharing, both are contributing single electrons to satisfy the octet rules. When they share these two electrons, both chlorine atom satisfying the octet rules, because each having single 7 electrons, when share with the other electron with the other atom, then become it is 8. So satisfy octet rule. So as single electrons contributed by both chlorine and the 2 electrons shared by the both atoms, so a single bond is produced between chlorine atoms in chlorine molecule. So chlorine molecule has a single covalent bond, and this covalent bond is produced between two chlorine atoms by sharing 2 electrons. So to form a covalent bond, 2 electrons is required. So this 2 electron contributed by both chlorine atoms. So a single bond is produced. If you see here, this is a chlorine atoms, this is another chlorine atoms, and this is the two electrons shared by both chlorine atoms. The first circle is first chlorine, second circle is second chlorine. So these two electrons remain between the two circles. It is a common point in between two circles where two electrons remain. That's why it has two electrons sharing. Okay, between two chlorine atoms, a single covalent bond is produced. You see these slides here, both chlorine atoms coming closer. Then each chlorine atom has 7 electron outermost shell. So if you see the each chlorine atom, 1 electrons remaining free. Other remain in pair form 6 electrons, that is 3 pair, and 1 electron is shortage to form pair of electrons. So when these two chlorine atoms come closer, these single electrons come closer and becomes a pair of electrons and forming a single covalent bond. That because for the formation of a bond, 2 electrons required. So each chlorine atom has a single electron in 2 single electrons in which form? Remain in unpaired form. So when both chlorine atoms come closer, both contributing single electrons, so it becomes a pair of electrons and forming one covalent bond. Then if you see similarly, what are the other examples of covalent bonds? If you see oxygen, here oxygen has 6 electron in outermost cells, and second oxygen also 6 electron in outermost cells. So what happens? So they have shortage of 2 electron to satisfy octet rules. To satisfy octet rule, both require 2 electrons. So what happens? When 2 oxygen atoms come closer, both contributing 2 electrons. So right side oxygen contributing 2 electrons and left side oxygen also contributing 2 electrons. So the contributed pair of electrons, that means 4 electrons shared by the both oxygen atoms in the oxygen molecule. So as 4 electrons shared between the 2 oxygen atoms, so a double bond is produced between oxygen molecules, and after formation of double bond, you see then same electrons, that is the non-bonded electrons, two pair of non-bonded, two pairs. That means first oxygen has 2 pair of non-bonded electrons and second oxygen has 2 pair of non-bonded electrons remaining in oxygen atoms, and both forming a double bond between 2 oxygen atoms by contributing 2 electrons by each, and this shared pair of electrons. How many shared pair of electrons are available between oxygen atoms? 2 shared pair of electrons, that is 4 electrons remaining between 2 oxygen atoms and forming 2 bonds. That is called 2 bonding pairs, that is called a double bond. So oxygen molecule has one double bond, that is 2 bonds remaining between 2 oxygen atoms, that is called a double bond. Similarly, if you see nitrogen molecule formation, here what happens? Nitrogen molecule has 5 electron in outermost shell, because nitrogen atom number 7, so 2 5, so it has 5 electron outermost shell. 5 means it has shortage of 3 electron in outermost shell. So what happens? As 3 electron shortage, both nitrogen atom contributing 3 electrons and forming 3 bonds, covalent bonds. These 3 covalent bonds produced between 2 nitrogen atoms. That's why it is called a triple bond. So nitrogen molecule has a triple bond, oxygen molecule has a double bond. This oxygen double bond containing 2 bonds and triple bond containing 3 bonds. To satisfy the noble gas configuration, the both nitrogen atoms, both oxygen atoms share their electrons. Oxygen share 2 electrons, oxygen contributing 2 electrons, each oxygen contributing 2 electrons, and 4 electrons shared by the both oxygen atoms. Here 6 electrons shared by the both nitrogen atoms, forming 3 covalent bonds that is called a triple bond. This is the structure of nitrogen molecule N triple bond N, indicating N2 molecule has 3 covalent bond and O2 molecule has 2 covalent bonds. It is called a single bond, it is called a triple bond. So this is the formation of a single bond, double bond and triple bond type of covalent bonds. If you see Lewis structure, what are the Lewis structure? Lewis structure indicate the number of valence electron available on the atom. For example, methane. As carbon has the atomic number 6, its configuration is 2,4. So 4 valence electron available in oxygen atoms. As 4 electrons available, it required another 4 electrons to satisfy octet rule. So when 4 hydrogen come closer, each hydrogen atom contributing 1 electrons and carbon contributing 4 electrons to 4 hydrogen atom. So 4 covalent bonds produced between carbon and hydrogen atoms. So 4 hydrogen producing 4 covalent bonds and carbon contributing 4 electrons and each hydrogen contributing a single electrons. So 4 number of covalent bond produced between the carbon and hydrogen and forming methane molecule. CH4 is produced by the formation of 4 covalent bonds. Because carbon has 4 electron in outermost shell, it requires another 4 electron, that's why 4 hydrogen combined with carbon atom forming 4 covalent bonds. Similarly, if you see carbon dioxide, as carbon has 4 electron in outermost shell, it requires another 4 electron. When you combine with oxygen, oxygen has 2 electron shortage. So what happens here? These 4 electrons of carbon, 2 electrons contribute for the formation of 2 bonds with the oxygen atom. Another 2 electrons of carbon contribute for the formation of 1 double bond, that is 2 covalent bonds with another oxygen atom. So carbon contributing 4 electrons, here contributing 4 electrons with 2 oxygen atoms and forming 4 covalent bonds, 2 bonds with 1 oxygen and another 2 bonds with second oxygen. So between carbon oxygen 1 double bond and another double bond between carbon oxygen with another oxygen. So here 4 bonds produced in CO2 molecules, that these 4 bonds are 2 double bonds. 1 double bond with the oxygen, another double with second oxygen. So carbon satisfying this octet rule. Similarly, if you see ammonia, NH3 is called ammonia. Here nitrogen, if you see electron configuration, nitrogen has configuration 2,5. 2,5 means it has 5 electron outermost shell. As it has 5 electron outermost shell, so it required another 3 electrons to satisfy octet rules. So what happens? As it required 3 electrons, so 3 hydrogen combine with nitrogen by contributing 1 electron by 3 hydrogen atoms. Each hydrogen contributing a single electrons combine with the nitrogen and it is sharing the electrons with 3 electrons of nitrogen forming 3 bonds. So one pair of electrons remaining on the nitrogen atom, which is called as a non-bonded electrons pair, remain on the nitrogen atom, and 3 electrons share with 3 hydrogen atoms and 1 electron pair, that is non-bonded electron pair, remain on the nitrogen atom. So 3 covalent bonds produced in ammonia molecule. Similarly, if you come to water molecule, here water H2O, oxygen, that electron configuration is 2,6, so it requires 2 electrons to satisfy octet rule. So to satisfy octet rule, what happens? 2 hydrogen come closer and each hydrogen contributing a single electrons with the oxygen atoms and forming 2 covalent bonds. As oxygen sharing, that oxygen contributing 2 electrons for the formation of 2 covalent bonds. So right side it is a shared pair of electrons with hydrogen, and left side also shared pair of electron with another hydrogen. So two covalent bond produce, the bond is OH, another is OH, and the remaining 4 electrons out of 6, 2 share, so 2 electrons contributing with the 2 hydrogen atoms, then remaining 4 electrons remain as called as non-bonded electrons, remains on the oxygen atom. So water molecule has 2 covalent bonds and 2 non-bonded electron pairs available on the oxygen atom. So this is the, we can say this is the Lewis structure of covalent compounds, covalent molecules, showing the valence electron in the oxygen in the covalent compounds. But in some cases it is being observed some covalent compound satisfy octet rules, in some cases shortage of octet rules, in some cases excess octet rule also satisfied. That will be discussed in your higher class. But you remember this, when non-metals combine each other, then the valence electron involved in the formation of covalent bonds. Then what are the properties of covalent compounds? First important property is covalent compounds may be a solid, liquid or gas. That means different types of covalent compounds are available. Some are solid, some are liquid, some are gas. Low melting point and high boiling point. These compounds, covalent compounds have low melting point and low boiling point, and they have also very low temperature required to melt and to vaporize. That's why that is called low enthalpy of fusion and evaporation. Enthalpy means heat. Low heat is required to melt and to vaporize the covalent compounds. So melting point is low and boiling point is low. That's why they have low enthalpy of fusion and vaporization. And they are very soft and brittle in solid forms, and they have a poor electrical and thermal conductivity. Their thermal conductivity and electrical conductivity very poor. Generally, they are water insoluble. As they are covalent compounds, they are water insoluble. So these are the very important properties of covalent compounds, and they are differ from ionic compounds. Just you can say the property just the reverse opposite of the ionic compounds. In case of ionic compounds, they are very high melting and boiling point, but covalent compounds are low melting and boiling point. Ionic compounds are water soluble, but covalent compounds are water insoluble. Ionic compounds conduct electricity, but covalent compound cannot conduct electricity. And ionic compounds are hard, and here covalent compounds are soft. So these are the some important properties of covalent compounds. Okay.